Assalamualaikum and a very good day. Hi everyone. We meet again in week 1 part 2 video. We still under topic first order ordinary differential equations, but now we will cover dependent and independent variables, the classification of differential equation, solution of differential equation, general and particular solution, and also the last one, initial value and boundary value problem. So at the end of this week, you should be able to determine the characteristic of ordinary differential equations. What actually is ODE? Ordinary differential equation is referred to differential equation which contain one or more functions of one independent variable and the derivative of those functions. Means that this ODE refer to a kind of equation that has here independent variable and also derivative that respect to this independent variable. For example, here we have, for example, dy dx equal to 8x. When your notation here in terms of dy dx, we say that this is a derivative of y respect to x. And this one is first order ordinary differential equation that we learn later. What does it mean by first order? What does it mean by high order? And then the second one, we have this kind of ODE. And also, the notation not only y and x. It can be any notation, any alphabet that is, for example, this one, we can also write it as dt. So now class, we want to know that, or we want to identify which one is dependent and independent variable. In an equation that involves derivative of one variable with respect to another, the former variable we call it as dependent variable and the latter is an independent variable. What does it mean? If let's say I have here dy dx, so in this case I can say that this equation involves derivative of one variable, derivative of variable y with respect to another means that with respect to variable x. And the former variable here means that this y here we call it as dependent variable. And then this x here we call it as independent variable. So this definition means that the derivative of the function, the derivative of one variable with respect to another, the derivative of y with respect to x means that here this y is dependent, this x is independent. We go to this example 1.2. Given a differential equation, for example, we have this differential equation, identify dependent and independent variables of the equation. So now we have here two variables, which is x and also t. If we refer back to this definition, the derivative of the variable, the derivative of one variable with respect to another. So here we can say that this differential equation have a derivative of x with respect to t. Means that here x is dependent variable and t here is independent variable. When you plot in graph, you will have here the dependent variable will be at y-axis. So here we have x, and independent variable will be on x-axis. So here x depends on t. And then we go to this example. We have this kind of differential equation, but this one is not in terms of ODE. It is in terms of PDE. So identify dependent and independent variable of this equation. If you see here, you have a variable u, x and y. So in this case, we have here derivative of one variable and respect to derivative of u here respect to x and y. Means that u here is dependent variable. And then for independent variable, we will have here two independent variables which are x and y is independent variable. When we plot this graph, we have here variable u depends on x, and also you will have two graph here, which is variable u also depends on y. Class, let's go to this example. List all the dependent and independent variables for each of the following differential equations. For this differential equation, the first one, the dependent variable here, okay, we see this differential equation, derivative respect of f and g respect to x, means that we can clearly see that dependent variable here is f and g, and our independent is x. In this case, the second equation, f is a derivative with respect to x. So we have here f is dependent variable and independent variable is x. For the third one, x is dependent variable and then our independent variable is t. And for fourth one, we have here f derivative of f respect to y and x. So f is dependent variable and our independent variable is x and y. And then for the last one, we have here f also respect to y and x, means that we have f is dependent variable and our independent variable is y and x. Okay, class. So next we go to the classification of differential equations. Differential equations can be classified by the first one, type, the second one, order, then degree, and then linearity. It is important for us to understand these four classification of differential equation, because based on this we can understand what method to be used to solve the differential equation. So we go one by one. For the type, actually differential equation, there are many types of differential equation, but we can here differentiate between the first one is ordinary differential equation and the second one is partial differential equation. Ordinary differential equation is the differential equation where the unknown function depends on only one independent variable. Remember, it depends only on one independent variable. But for PDE, the unknown functions depend on two or more independent variables. So for this chapter, for this course, you only will learn about ordinary differential equation. Will not go to the partial differential equation. And based on the order, the classification of differential equation based on the order means that the order here refer to differential equation where order has the order of the differential equation here is the order of the highest derivative appearing in the equation, not affected by any power to which derivative may be arise. So here, for example, here we have dy dx plus we have dy dx power 2. So the order for this one is refer to the highest derivative appearing in the equation. The highest derivative here for this one is a first derivative. But if you see, this one is power 2. So we go to the second concept, not affected by any power to which the derivative may be arise. In this case, means that this power not affected the order. So the order for this differential equation is 1. It is not affected by this power, but it is only the derivative or the highest derivative appearing in this equation. The degree. Degree here is the power of the highest order derivative term in the differential equation. Means that if we refer back to this one, the degree for this equation is 2 because the degree refer to the power of the highest order derivative. The highest order derivative in this equation is 1 and the degree for this one for the highest is 2. So the degree for this differential equation is equal to 2. Linearity, it means that the dependent variable and its derivative are of degree 1. Remember, only degree 1. Degree 1 means here there is no, the power of that differential equation is 1. There are no product involving the dependent variable with its derivative. Okay, means that no product involves dependent variable with its derivative. So you have to know which one is dependent, which one is independent. In this case, it's referred to the dependent variable and its derivative. There are no nonlinear function of the dependent variable. Nonlinear function here refer to, for example, quadratic function, sine function, exponent function, logarithm function, and so on. So if this function in that differential equation means that differential equation is nonlinear, because for linearity, no nonlinear function of the dependent variable. Remember, again refer to dependent variable. If it is for independent variable, it is okay. Okay, for independent variable means that we can say that the differential equation is still linear differential equation. Okay, class. Classify the following differential equations by type. So by type we have learned we have two types, which is ordinary differential equations and partial differential equations. For ODE, it is respect only to one variable. Okay, one variable of independent variable. Okay, and for PDE, it can be one or more. So in this case, we see for number 1, dy dx equal to 2x plus 9. So now we have only, okay, y is dependent, and then x is independent variable. So now we see that the differential equation here is derivative only respect to one independent variable, means that its type here is ODE. And then number 2, we see we have here one dependent variable with respect to two independent variables. In this case, x and y is independent variable. So when we have one or more independent variable, we say that it is PDE. Okay, and then number 3 here. Okay, number 3 here we have here, which is only one independent variable, so it is ordinary differential equations. But for number 4, we have here two independent variables, which is p and x. So here we say that it is partial differential equation. And then class, we need to classify for this example by order. So in this case, remember, order refer to the highest derivative. Order refer to the highest derivative of the differential equation. In this case, for number 1, the highest derivative here is clear. It is 1. So it is order 1. And then for number 2, the highest derivative here is, this one is 1 and this one is 2. So the highest derivative here is 2. If you see, you have here power 2. But remember, for the order, it is not affected by the power. So now, the highest derivative in this equation is 2, means that it is order 2. And for this case, the highest derivative in this equation is 3. This one is 1, this one is third order. But although this one power 7, remember, order is not affected by the power. Means that for this one, the order of this equation is order 3 or third order. For this number 4, the order for this equation is second order or order 2. Next class, we need to classify the following differential equations by the degree. Remember, what does it mean by this degree? It is power of the highest derivative. Okay, so in this case, we check. For this one, we have the power for the differential equation. There are this one, it is power 2, this one, it is power 3. But we need to check for the highest derivative. Highest derivative here refer to second order. Refer to this one, second derivative. Means that the power of the highest derivative here is 2. So it is degree 2. And for this case, the power of the highest derivative for this one is only 1 because this one is power 1. Although its derivative is 2, but the power here is 1. So for number 2, it is degree 1. Next class, we need to classify the following differential equation by linearity. Okay, for the linearity, we have here number 1, degree of derivative and dependent variable must be 1. Then no product involving derivative and dependent variable. And number 3, no non-linear function of its dependent variable. So if we check one by one here, for number 1, we see that there is no degree of the derivative and dependent variable for all these are 1. This one, the degree is 1, and here for this y also 1. What does it mean by degree? Degree refers to the power of the derivative and dependent variable. And then we see here, no product, okay, no product involving derivative and dependent variable. Means that there is no y times dy dx, for example. No y times second derivative of y respect to x, for example. And then no nonlinear function involving dependent variable. In this case, it is nonlinear function. But nonlinear function here just involve for independent variable. Please take note that nonlinear function in this case is a nonlinear function for dependent variable. If you have your y to the power of 2, so it is nonlinear. But now this is independent variable, so for number 3 also fulfill, means that this example 1 is linear ODE. For this number 2, if you refer here, we have here y to the power of 3. When we have y to the power of 3 means that degree of this dependent variable is not 1. And then it is actually non-linear function of this dependent variable of this y. So in this case, for the equation number 2, it is non-linear. And then for equation number 3 here, we can see the degree for this equation, okay, the degree for this one is 1, but the degree for dy dx is 4. When the degree for this one is not 1, means that it is non-linear. So number 3 is non-linear. When we see for number 4, we have here, okay, this one actually degree is 1, but we have product involving derivative and dependent variable, which is for this one y times dy dx, and this case is not fulfill condition number 2. Means that number 4 is nonlinear ODE. Then we go to the number 5. For this number 5, we see that the degree of the derivative here or its dependent variable is 1. Okay. And then no product involving derivative with dependent variables. This product involved with independent variables, so it is okay. And then no nonlinear function involving dependent variable. This one, there is nonlinear function, but it's involved independent variable. Means that for this number 5, it is linear. And then if we go to this 6, okay, 6, clearly we have sin y here. When we have sin y here, means that it's not fulfill condition number 3. Whereas here we have a nonlinear function involving dependent variable, so this one is non-linear. And the last for this number 7, it is here is a linear function because degree of the derivative here is 1. No product involving derivative of dependent variable, okay, and also no nonlinear function involving dependent variable. This one only, this for x squared is for independent variable. So this number 7 is a linear function.